All right, 8.6, the law of sines. Students will be able to solve triangles by using law of sines. Here's the main thing with the law of sines. This is the formula right here. In order to use the law of sines, you need to have at least one angle and a side across from that angle, and then another side or angle. Okay? One other thing. So you need to have three things total, but you need to at least have a pair of opposite angle and sides. So whether it's, this angle on this side, or this angle on this side, or this angle on this side, doesn't matter, and then one other side or angle. So, for example, in this first question here, we have two angles and a side. And if we wanted to, we could get a third angle pretty easily, right? I mean, we know these two angles, and we could find the third angle by just adding these two up and subtracting it from 180. So let's just do that real quick. I'm going to do that on my calculator off on the side here. So 180 minus 68 and minus 37 is 75. So just in case you find yourself in a situation where you need to find another side or the angle across from the third, or the side, I'm sorry, across from the third angle, you can always find the third angle, right? So that's an old trick. All right, they want us to find side B here. Well, B is across from 68. And again, in order to use the law of sines, I need to have one pair of opposite angles and sides, which I have right here. And so let's look at the formula. Formula says that I just put the side over the sine of the opposite angle and set it equal to the side over the sine of the opposite angle. The three parts of the equation here is just saying that you could use any two of the three. So for example, I could cover this up and just have A equal to C. I could cover this up and just have B equal to C. Or I could cover this up and just have A equal to B. It doesn't really matter. You can set it up any way you want. The other thing is, this is written with the sides on top. It doesn't have to be. You could write it with the sine of the angles on top as well. But generally, you want to put whatever on top that you're trying to find. So we're trying to find side B here. So we're going to put that on top. So I'm going to start this problem off with B over the sine of B equals, what do I know? I know A and side A. So I'm going to say equals A over sine A. And now let's just plug it in. I don't know what B is. I do know, though, that angle B is 68, so I can put this over the sine of 68 degrees equals side A is 3 over the angle across from that is sine 37. Now all I have to do is solve for B. That's pretty easy to do because B is being divided by sine 68, so multiply by sine 68. We got to do that to both sides. These things cancel. So B equals 3 times sine 68 divided by sine 37. And we're ready to just put that in our calculator. And when I plug that in my calculator, I end up with B equaling 4. I'm going to give you 3 decimal places for now, 622. And whatever units it is. They didn't give us units for this problem, but we would have that. Okay, well now we have found side B. So for practice number 1A, I want you to find side AB. AB is this side. It's across from angle C, which we've already found. So it should be pretty easy for you to do. Go ahead and give that a try, and then I would unpause the video to see the correct answer. Okay, so I just wrote out C over sine C equals A over sine A just to get used to using the formula. I plugged in everything I knew except for, of course, side C, which is the same thing as AB, right? AB is side C, so that's why I just said C. C over sine 75 equals 3 over sine 37. I need to get the C by itself, so I just multiply both sides by sine 37. And then I just plug this in my calculator, and I get 4.815. Done. Pretty easy to do. All right, example 2, it says, find the measure of angle Z to the nearest degree in triangle XYZ if Y equals 17, Z equals 14, and the measure of angle Y equals 92. So now we're trying to find an angle. And again, this sine A, sine B, sine C, that's just referring to a triangle where you label it A, B, and C. If it was X, Y, and Z, you would just do the exact same, but replace it with X, Y, and Z. Or PQR, or it doesn't really matter what the letters are, it's just know that you can set the side over the sine of that opposite angle equal to another side over the sine of that opposite angle. So, as we look at this problem, remember I said when using law of sines, start with whatever you want to solve for on top. Well, I want to know what angle z is. And the angles goes with the sine, so I'm going to write the sine of z over side z equals, what else do I know? Well, I know side y and angle y. So I'm going to say the sine of capital Y over side y. Now, I didn't plug anything in yet because I just want to show you how you could set this up. So my next step is the sine of z, capital Z, which I'm trying to find, over, well, I know side z is 14, equals the sine of angle y, which I know is 92, over side y, which I know is 17. Now it's just all about solving for z. Remember, my goal is to get this thing on top first, this or all by itself first, this sine z all by itself. So to do that, I'm going to multiply both sides by 14. That cancels out. And now I have that situation where I have the sine of an angle equals something else. So I'm going to need to do the arc sine of both sides. We did this before. Now when I do that, the arc sine and the sine cancel out, so I finally have z equals the arc sine of this whole thing, sine 92, I'm going to do parentheses times 14. Typically we put the 14 in front, but I kind of just forgot to put it there, over 17 in parentheses. And now we're ready to put it in the calculator. Again, maybe it'd be easier if you put the 14 in front, so I'm just going to write that real quick. A better way of kind of putting this in your calculator and thinking about it is 14 sine 92 over 17. And so, yeah, we're ready to just plug in our calculator, so let's go ahead and do that. I'm going to press arc sine first, and then 14 times sine 92 divided by 17. And I get that angle z, I'm going to just write it up here, is 55.39 degrees. I rounded to the nearest hundredth there. Okay. There we go. Let's see, this next part here. This is says solving a triangle. Means finding the measure of all the sides and the angles. So when they say solve this triangle or solve a triangle, it means you should know all three sides and you should know all three angles. So let's do that here for example number 3. It says solve triangle ABC, so we know this angle, we know angle B, and we know side B. Looks like we could find angle C pretty easily. So let's do that first since that seems like the easiest step. Again, all the angles should add up to 180, so 180 minus 33 and minus 47 leaves us with 100 degrees. So I'm just going to make a note real quick that angle C is 100 degrees. Alright, so now that just means we need to find side A and side C. And then we would have all three parts, right? So let's go ahead and try and figure that out. Since I have one side and its opposite angle, I can use the law of sines to find either other side. So I'm going to go ahead and find side A first. I want to know side A, so I put it on top, over the sine of angle A, which is 33. Set it equal to side B, which is 14, over the sine of angle B, which is 47. I want to solve for A, so I need to get it all by itself. Right now it's being divided by sine 33, so I multiply it by sine 33. And those things cancel, and now I'm ready for the calculator. So 14 times sine 33 divided by sine of 47 equals 10.46. what they say here, they said round your answer to the nearest tenth. So if I round to the nearest tenth, it's just 10.4. So I know A now is 10.4. I can now find C. I'm going to use pretty much the exact same setup, but I'm just going to put a C in. So let's just do it here. I'll do it in blue. C over sine. What's the angle across from C? It's 100 equals, same thing. I'm going to set it equal to 14 over the sine of 47. Just do a little bit of algebra. Multiply both sides by sine 100. These things cancel, and again, I'm ready for the calculator. So C equals 14 times the sine of 100 degrees divided by the sine of 47 degrees, and we get, rounded to the nearest tenth, it would be 18.9. Okay. And now we have all the parts. I could just plug that in up here as well. That's an equal sign, even though it looks kind of like a Z. So I know all three angles, I know all three sides, therefore I have solved the triangle. I want you to go ahead and try and do the same thing here. It says solve triangle ABC. They give you, this one they only give you one angle and two sides. So it might take you a little bit of work, but go ahead and give it a try. So you're looking for angle A, angle B, and side A. I'd pause the video, give it a try, and then unpause it when you're ready to check your work. Okay, so the first thing I did is I tried to find angle B since I already knew side B. So I said sine of B over side B of 14 has to equal the sine of angle C, which is 98, over side C, which is 20. Went ahead and solved that, ended up with getting angle B equaling 43.88. I then can very easily find angle A because I know that this angle and 98 have to add up to 180. So 180 minus 98 minus 43.88 is 38.12. So now I have all three angles. I just need all three sides. I already have two of them. I just need the third side, which is A. So I put A over sine of A equals side C over sine of angle C. I multiply both sides by sine 38.12. Cancels out, and then I just plug this in my calculator and I got side A. So it's pretty straightforward, just using the formula. Let's go to the next page. And now we get to use it in some word problems. It says when the angle of elevation to the sun is 62 degrees, right away we know this, angle of elevation to the sun is 62 degrees, a telephone pole tilted at an angle of 7 degrees from the vertical casts a shadow that is 30 feet along the ground. Find the length of the telephone pole to the nearest feet and inches. Well, we have to draw this, okay? Let's draw this. So the first thing I'm going to draw is the ground. And then we have some telephone pole. It says it's tilted out slightly. And what do we know? It's casting some shadow. Well, if the sun's over here and it casts some shadow like so, we could say this is the S for shadow and this is P for pole. We know that this angle of elevation is 62 degrees, so let's go ahead and put that in. And we know something else. It said that this pole is tilted at an angle of 7 degrees from the vertical. So if I was to draw a line straight up and down as the vertical, it's kind of confusing, but that would mean that this is 7 degrees. Well, that's not that bad because the vertical is always 90. So we actually could find this angle here. We know this angle because it's going to be 90 plus this 7 degrees. So this angle is actually, I'm just going to draw a little arrow, is actually 97 degrees. Well, with that information, if we know that this angle is 97 and we know this angle is 62, we could easily find this angle up here. So let's do that. 180 minus 97 minus 62 leaves 21. So this angle must be 21 degrees. All right, what else do we know? We know that this shadow along the ground is 30 feet long. So let's go ahead and say that equals 30 feet. And they want us to find the length of this pole, even though it's tilted. No big deal. We have a side across from an angle, and and we have an angle across from a known side. So we can use the law of sines. I'm going to put what I want to know on top, P for length of pole, over the sine of the angle across from P, which is 62 degrees, equals the side of 30, which is the shadow, across from the other angle, sine 21. Solve it real quick by multiplying both sides by sine 62. And these cancel, and we're ready to go to the calculator. 30 times 62 divided by sine 21. And that equals, find the length of the telephone to the nearest feet and inches. That is very interesting. So first, let's just find it to the nearest feet. So we got P equals 73.914 feet. But they want in inches. So here's what we got to think about. This is 0.914 of a foot. So we need to multiply this by how many feet are in inches, which is, or sorry, how many inches are in a foot to figure out how many inches we have. So we already know that we have 73 feet. And inches, we're just going to do 0.914 times 12, which is 10.9. So I'm just going to say 11 inches. So 73 feet and 11 inches, almost 74 feet. All right. You know, I just realized this is actually kind of a bad question, because there's another possible way of doing this, and maybe you thought of it this way, and that's okay if you did. That's why it's a bad question, because there's actually two answers. I drew this pole tilting to the right. I could have just as easily drew this pole tilting to the left. I'll just show you in red, which would not make this 97. It would make it 90 minus 7. It would make this 83. And it would change everything. It would change this angle to 35. And so it would change all your math that you do here. So I just want to say that this question is actually not that well written. So for the sake of argument, let's just say that the picture is how I described it, and hopefully we'll have some problems with some better descriptions before we try and solve them in the future. Okay, last thing I want you to do is take a look at the summary. It says, take a look at what information is needed when using the law of cosines compared to using the law of sines. How could you tell if you need to use the law of cosines or the law of sines in solving a problem? Answer it in complete sentences. Go ahead and give that a try, and I'll see you guys in the next video.